Close your eyes and think of the night sky. Doesn't it remind you of a dark background with dense stars? Of course, the night sky is dark. This is because there is no sunlight unlike during the day. This time, think of a wooded forest. Can't you see dense trees everywhere from where you stand? The trees near you will look big and the trees far away will look small. But most of them will eventually come into view. Have you ever thought about this while looking at the night sky? Why isn't the night sky bright? The reason why the universe is black is because it is very wide and empty. The size of the universe is about 93 billion light-years. The distance light can travel for 93 billion years. 90% of the universe is made up of dark matter, which is invisible to us. The other 10% is made up of dark energy and matter, including stars, planets, gases, and dust. This obvious and absurd question has actually been a question that has plagued astronomers for more than 100 years. If you hear this question, you will think it's because of the sun. But the reason why the night sky is dark is not because of the sun. Because we have to explain why space is dark. The fundamental reason why the night sky is dark is that the outer space is black. So the night sky without sunlight looks dark because space is black. Today, we're going to talk about why the universe is so dark and why the night sky is so dark. A star is a self-illuminating celestial body, like the sun. And other planets and celestial bodies that aren't stars can't emit light on their own. And they're receiving light from stars like the sun. So the temperature rises and the light is reflected back, and they're shining like stars in our night sky. There's one star in our solar system called the sun. And in this solar system, there are planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and countless other planets. And self-luminous stars like this sun are known to have at least 500 to 600 billion water in the galaxy. The Andromeda Galaxy, the closest galaxy to our galaxy, has more than one star. And to date, there are about 170 billion galaxies in the universe that humans can observe. And most galaxies differ in diameter by 1,000 to 100,000 parsecs. How many stars does this observable universe have in its 170 billion galaxies? As I said, stars emit light on their own. And other objects are reflected from the planets. Because there's volume in a star. A straight line that extends into the infinite universe will one day reach the surface of the star. In other words, when light is emitted from a universe of countless stars, the end of the linear distance in the direction of the light will eventually touch the surface of the object, and the object that receives the light will reflect it back and scatter it into space. So the night sky that you see from Earth should actually be as bright as the surface of a star. Simply put, since the universe is full of stars, the universe should be brilliant. But the reality is that if you think the night sky is much darker and full of stars, it's only about 1/10 of a trillion brightness. If there are many stars in the universe that are evenly distributed and shining, the night sky will look like a lot of suns rising. There are scientists who have long considered such a simple, but not easy problem. The first person to give an opinion on why the night sky is so dark is called Olbers' paradox. The 19th century German astronomer Heinz Olbers was observing the night sky when he suddenly wondered, why is the night sky dark? And eventually, this problem has plagued astronomers for over 100 years in the name of Olbers. Here's what the first servant thought about. If the universe is infinitely wide, and stars that emit visible light spread evenly throughout the universe, shouldn't the Earth's night sky be as bright as the sun's surface? The answer to this question was the gas layer absorption theory. Olbers argued that the reason why the universe is dark is that interstellar gas, dust, etc. block the starlight and cannot reach us. It is the same logic that visibility drops on a day when fine dust is severe. However, when a substance absorbs energy for a long time, the temperature rises and emits light on its own, which is called a light-emitting nebula. The Orion Nebula is a typical example of a nebula that receives energy from high temperature stars and emits light by heating gases and dust. According to Albert's argument, the light of the luminous nebula should be visible instead of starlight. But this argument was not established. But this Albertian theory of gas absorption couldn't really explain why the universe was dark. Because when it's blocked by a star's light transmitting matter in outer space, it's heated up by the light, and it emits light again. This is because the dark voice observed in the universe will no longer be a dark temple, but a luminous nebula, shining like the sun. Plus, the universe is basically empty. So there's a lot more transparent than opaque areas. So even considering the sexual material, Wolf's paradox didn't explain since then. There have been various opinions. Some of them were saying that the light from distant objects could not reach Earth, because the intensity of the light decreases as the distance of the light increases. But the more distant the light is, the less intense it is, because the luminosity is inversely proportional to the square of the distance. But the area of the sphere with that distance, as its radius also increases in proportion to the square of the distance. And so the number of stars that light reaches. When we light a flashlight close to our daily lives, the area of light is reduced. But the area of light can be bright. But if you use a flashlight to illuminate the distance, the light will decrease in brightness, but the area of light will increase. So, even if the light intensity decreases because of the distance, more celestial light can reach as the light reaches a larger area, which leads to more light diffusion, so it can't really explain why outer space is black. Since then, many astronomers have been troubled by this paradox. And an American writer first provided the clue. American mystery writer Edgar Allan Poe had a special interest in astronomy, and published a collection of poems titled Eureka shortly before he died. This was a summary of all the astronomical observations he had collected during his lifetime. This is what stands out the most. If the universe is made up of countless stars, the night sky must be brilliantly bright, because there is no reason to be a space where stars cannot exist in a vast space. Therefore, we can only think that most of space seems empty because the light emitted from distant objects has not yet reached our eyes. Edgar Allan Poe's idea of being based on scientific evidence alone was a crucial clue to the right path for astronomers. In 1901, Sir Kelvin, a Scottish physicist, solved the history of Olbers, and the logic he used was: when we look at the night sky, we're not looking at the stars at this moment. We're looking at the past of the stars, so the light emitted from the stars is transmitted at a tremendous speed. But because of its finite speed, it must take time to travel a certain distance. And if stars are very far away, the time it takes for light to travel from there to Earth could be over 10 billion years. And Lord Kelvin, from a simple calculation, concluded that for the night sky to shine, the universe must extend at least a few 100 trillion light-years. But our universe is not that old yet. So it's what makes the night sky look black. And the second reason is that because stars have a finite lifespan, all stars, including the Sun, go through similar processes, repeating life and death. And the cycle is about billions of years, repeating light emission and disappearing. And the universe doesn't shine brightly. This seemed quite convincing because it was not discovered at the time that the universe was expanding. The U.S. astronomer Edwin Erb cleared Wolvers's history. In 1929, Edwin Hubble discovered that almost all galaxies had red convenience in their spectrum. And based on that, in the case of stars that are very far from Earth, even if they emit light, by the time they reach Earth, the wavelength of light increases, turning into invisible. Infrared are propagating, and the galaxies move away from us, and the universe expands. So, in the case of stars that are very far from Earth, it's hard to reach as space expands, even if they emit light. As the universe expands, galaxies above the distance are moving away at a faster rate than the speed of light. So it was concluded that we could never reach Earth. This boundary is now called the cosmological horizon in cosmology. The range of the universe that we could observe was limited. So to sum up, if the universe doesn't expand, the night sky should actually shine at the same brightness as the sun, through the light images of stars and the critical history of celestial bodies. But as the universe expands, the light of galaxies within a certain area increases in wavelength, due to red convenience, turning from visible light to invisible. Infrared or radio waves, and many galaxies above a certain level, are moving away from Earth at a faster rate than light. In short, the speed of light has not yet reached us because it is finite. And even if it comes to Earth over time, it will never be seen because the rate of expansion of the universe is faster than the speed of light. Also, the universe is a redshift phenomenon that occurs as it expands, and starlight is only observed in infrared light. So it cannot be seen with the naked eye. Stars emit light, but that light often cannot reach our eyes, because the universe is too wide. Also, there are many clouds in space, which block light. So, we can only see the light in space, and the rest of it looks black. The reason why the universe is black is because it is very wide and empty.